When I first came to Clojure, I remember being utterly confused by the sum function. The name just didn't make sense, and I found its behavior non-obvious. I think the reason is that it's one of those general utility functions that can be used in sometimes surprising ways. Let's start with the basics. The pos function checks if a number is positive, so greater than 0. The sum function takes as its arguments a function and a collection. In this case, we pass it the pos function and a vector of numbers. If some of the numbers in the vector are positive, in other words, one or more of them, then sum will return true. Conversely, if none of the numbers are greater than 0, then sum returns a falsy value, nil. So that explains the name. The function must be true for some of the items. It's like applying the function to each item in turn and then combining the results with a logical OR. Notice how we get the exact same results for the same numbers. It seems the version with OR is equivalent to the version with sum. Pos is a function that always returns true or false. But what if we use a function that returns some other value, like a string or a map or nil? OR will treat nil and false as logically false, also called falsy, and any other value as logically true or truthy. The return value of OR is the first truthy value it encounters. The sum function is similar. It passes each value in the collection through the supplied function, and the first truthy value it encounters, it returns. Suppose I have a friend visiting from afar. Isn't that a joy? My friend is dying for a cup of tea. Luckily, I have my shelves neatly arranged, so I look for the box labeled tea and get its contents. Remember that Clojure keywords can be invoked just like functions. Pass them a map and they will look up the value in the map that corresponds with the keyword, or nil if the keyword is not present in the map. Sum will first check the cake box, but won't find any tea there. The second box does contain tea, which sum returns, so now I can brew my friend a lovely cuppa. Now, let's look at 3 specific use cases for using sum. The first use case is to check if a collection contains a certain value. While learning Clojure, you may have noticed that there is no generic function for checking if a collection contains a certain value. Sets do support this operation. You simply use the set as a function, and it will return the item if it is in the set, or nil otherwise. Other collection types don't support this operation, because it can't be done efficiently. It would require a linear search through all items of the collection. Sometimes, though, that is exactly what you want. In this case, the Clojure way is to combine sum with a set literal as a function. Sum will go over the vector, calling the set with each value in turn. Most of the time this will return nil, but when checking the a keyword, the set will return the keyword itself, which is truthy, so the search stops and sum returns a. This gives us a concise and idiomatic way to check if an element is present. The second interesting use case for sum is as an alternative for apply OR. Suppose you have a sequence of values, like this vector, and you want to find the first value that is truthy. There are several ways you could go about this. You could filter out the falsy values, and then take the first value of the result. Notice the use of the identity function here. It's a function that always just returns its argument. Not terribly useful by itself, but often useful when combined with higher order functions. These are functions which take another function as one of their arguments. Conceptually, you may have noticed that this is again the same as doing a logical OR. But we have the arguments in a vector, so we need to somehow expand them to individual arguments. The Clojure way to expand or split a variable number of arguments would be to use apply. Unfortunately for us, that doesn't work. OR is not a regular function, it's a macro, and so we can't pass it to another function like apply. Whenever you find yourself wanting to type apply OR, type some identity instead. Since sum works almost exactly like OR, this does what apply OR would do. Finally, let's see how sum can be used to stack request handlers in a web application. For this example, imagine you have a web app that can respond to various HTTP requests. Web applications in Clojure typically follow the ring specification. This simply means they are functions, which receive a Clojure map representing the request and return a map representing the response. Right now, we don't do anything with the request yet. We always return the same response, a 200 OK status containing the text, "Hello, home." But really, this response is only suitable for the home page. If people visit the About page, they need to see different content. Let's fix this by checking the URI and request method. Clojure's destructuring syntax makes it easy to pull these out of the request. The About page handler is identical, except that it responds to a different URI path and returns different content. These handlers are now a bit more selective. When calling the homepage handler with the correct URI for the homepage, it will return a response, but any other URI will cause it to return nil. Because of this selectiveness, we can now easily combine them with a logical OR. If a handler ignores the request, then the next one will be called, until one responds. By now this pattern should look somewhat familiar, although it is a little bit different from what we were doing before. Instead of calling the same function several times, each time with a different argument, we now call a different function each time, always with the same argument. Luckily, functions are just data, so we can iterate over them just as well, and use a small inline function to apply them to the request. Now our handlers are listed in order, and it's trivial to add new ones to the list. The good thing is that we don't have to implement this ourselves, because the Composure library comes with a function that does exactly this. Let's refactor this in steps. First, we use the routes function, which takes our handlers and returns a combined handler, which we then call with the request. This is still a bit wordy. Composure comes with a macro called defroutes. It provides that extra bit of syntactic sugar to make this code nice and concise. And now our requests are dispatched to the right handler, just as they should. I hope you enjoyed this deep dive into a surprising little function. Till next time!